Hello everybody again. I'm back with some further videos on the RTB2004. Sorry for the long delay. I was planning to produce some videos just before New Year or the very early part of January, but I have a major back problem, and right at the end, on the 30th of December, I put my back out. I've had 5 back operations previously, and right at the end of December I was trying to help my son do something with his car brakes, replace some brake pads, and I twisted badly, and for about 3 days I literally was in agony and couldn't move, and it's only just been in about the last week that I've started to get back to normal work again and try and catch up on everything that ran well behind. But anyway, I'm back now, and we're going to do some more videos on the RTB2004. This video is only a relatively short one, although I say most of the videos are short and then they turn out to be quite long. This video is just looking at the power usage of the RTB2004 using my Metrahit Energy Meter, which is a rather nice meter I use mainly for measuring DC power usages, but it actually measures AC as well, which I don't tend to do a lot. I tend to do more use of it for measuring microcontroller current draw and power wattage usage, but it's ideal for also measuring AC highly accurately. It's quite an expensive meter, but very accurate. So this video I'm using that to show the standby usage in watts of this scope, and also its running usage in watts compared to my Rigol, and also compared to the Keysight, being the 2 other scopes that I have. I'm also showing in this video a signal, a 10 megahertz signal that's coming from a temperature controlled oscillator that I brought off eBay. Somebody had asked me could I just show some basic signal being displayed on both the Keysight and also on the RTB2004, just to show how the screen real estate being larger makes a difference. So I've sort of basically shown a 10 megahertz sine wave, and I've put the statistics mode on, which was something I was doing the other day when I was logging something and looking at stats, and it just makes it much easier to use when you're because of the larger screen display on the RTB. It just is easier to read and see things. The Keysight, which I still like the scope, and it but I must admit I'm reaching more for my RTB most of the time now. The Keysight, by the time you put a lot of information on the screen, it just becomes a little bit small, whereas you've just got a larger real estate. Also, of course, I've got the ability with the RTB2004 to display it on a Mac or a PC. I don't have the network software interface, because the Keysight you have to buy an additional card, which is about £300 for I know there are available plans to make your own from a PCB, but the software is still not as good either. The RTB software, which I've got another video that I've done previously showing the software, is just phenomenal, and it works. I've got my RTB on my network at the moment. Funny enough, for this video I've actually unplugged it because I moved it to a different site, but normally it's plugged into my network, which means I can be looking at it either on my Windows machines. I've got an iMac which I can look at it on, or even on my tablet, because it's all on my network. So I can look at it anywhere basically on my network around my lab, which is really great. But anyway, I'll move on. So the first thing I'm going to show is the usage of the RTB in terms of its wattage using the Metrahit Energy Meter I've got, and then I'm going to show the statistics mode and compare that with a display of a sine wave on the Keysight, and then compare it to the RTB. I will be producing some further videos in the next few days, and I'm probably going to produce a video showing the logic channels on the RTB2004 because I was using something recently, and I just thought it might be worth. There's not many videos out there that show the logic channels. They've got 16 logic channels on this, and I was doing something the other day using the logic channels, and it's quite impressive. So I'll show you the logic channels of the RTB, which will be in another video in the next 3 or 4 days. Hopefully I'll get that down there and that will be uploaded. But anyway, we'll get on with this video, and we'll now have a look at the power usage first of all, and then we'll compare the display after that. Okay, I hope you enjoy the video. Right, I'm using my Metrahit Energy meter now to take some readings of the standby usage in watts and also the usage once the RTB is switched on. There's been a few comments on things like the key sight that it uses a very high standby wattage, which I've measured myself using this Metrahit Energy, which is a very accurate meter, and it comes out at about 6.47 watts unbelievably in standby, which is quite bizarre really, with the amount of energy that uses just in standby, particularly as I don't believe that it actually keeps the crystal heated. I think it's got a temperature controlled oscillator in the key sight, but I don't think it's actually an oven oscillator. You can see from the display at the moment on the Metrahit Energy we're running in standby mode, so it's just illuminating the standby light at about 0.45 of a watt. Now I measured my Rigol, because I've got 3 scopes. The Rigol DS2000 series standby takes between 0.48 and 2.74 watts. It pulses because of the front light, and pulses at full brightness, goes up to about 2.7 watts. The key sight, as I said, is about 6.4 watts, which is just bizarre, and this is running at about 0.43 of a watt, so it's very efficient when it's in standby. Not that I tend to leave it all the time powered up in standby, but at 0.4 of a watt one could quite easily and quite happily do that. If I switch this on now, so I'm just switching that on, and it's booting up, I think it'll take, from my past notes, it's going to take about 40 something watts. It does vary slightly depending upon what mode you've got on and what you've got switched on, but it's running at the moment. I've got this 10 megahertz signal still being displayed with the statistics mode on, so let's put the statistics mode on, and it's running at about 44 watts at the moment, so it's 239 volts in the lab, and it's drawing about 297 milliamps, which gives you about 44 watts. It will vary slightly dependent, funny enough, upon the brightness of the LEDs, which shows how accurate this Metrahit meter is. So if I go in and alter my brightness of my LEDs on the front panel by doing that and then altering my brightness, I'm dialing that right up now to 100% brightness, and my wattage has gone up to about 45.4. 45.3, it's varying a bit. If I dial that down, that's at 100%. If I dial the LED brightness right down, so I've dropped it now to 20%, I'm down to about 43 watts. So it's about 2 watts I've noted difference between 20% LED brightness and the full brightness. I normally run the front LED panels at about 40%, something like that, because I find that's more than bright enough. It doesn't require anything further and anything brighter than that. But it's quite interesting that on standby this uses virtually nothing. The wattage does vary a little bit dependent upon the amount of memory you're using and things like that, but fundamentally it's around about the 44 watts, which compared to the Rigol, when it's running, it's a little bit more, but of course the screen's bigger. The Rigol, I found when I measured it recently for this video, was drawing about 30.33 watts running with 2 channels on, or 2 or 1, actually didn't make any odds. This is running 1 channel at the moment, it's running at 44 watts, and the key sight again is the most power hungry at about 65 watts when it's running with 2 channels on, and I think it drops. Funny enough, the key sight, actually I switched the screensaver on and it went down by about 4 watts, so the screen of the actual key sight is drawing about 4 watts itself, because with the screen, there's no screensaver on this, so I can't do the same experiment, but even with the screensaver on, the key sight's still running in acquisition mode, but with the screensaver on, so the screen is not being driven with any backlight, or was running at about 62 watts as opposed to 66 at maximum. But this is the most power efficient, or more power efficient rather, than the key sight. Obviously it's using more energy than the Rigol, but that's not an awful lot of difference. Where this does come in very efficiently is when it's on standby mode, because if I now switch this back to standby mode, so I've turned it back to standby mode and we're back down again to 0.43 of a watt, and it will stay at that. So it's drawing now about 22 milliamps, which I presume purely is for the LED on the front. And I'm not quite sure what else it would be running inside. I don't think the fan would be off now, etc. The 44 watts that this draws when it's running is fairly constant. It doesn't seem to change much with the fan coming on or off. I ran it for about half an hour to do an energy check, and it was on average about the 44 watts. But anyway, that just gives an idea, because a few people recently have done some tests of wattage on their equipment, just to see what it uses in terms of things like the Rygo, and also particularly the Keysight's been slated for using 6.5 watts in standby. But even with the Keysight, I don't actually leave my Keysight plugged in all the time anyway. Even when it's in my lab and I switch it off, I've got a master switch that switches my power feed off to various items like a function generator and the scopes, etc. So I don't tend to leave them powered on all the time anyway. I just don't see the need to. If I want to preheat them, I'll put them on and leave them on for half an hour before I start measuring anything, and then when I finish for the day I switch them off. One thing that is worth stating on the Rohde Schwarz, which I forgot to mention previously, is that when it's set up and you've set everything up to take a signal, and you might have put the time base in, set the channels up to certain voltages per division, etc. When you switch it into standby mode, it remembers it, which is a real pleasure, because I might set something up at night time, decide that I want to have a look at it tomorrow morning, and I can just switch it back on. So when I go and switch this back on again now, so it's booting up, and of course this boots up in about 8 or 9 seconds, which is phenomenal, whereas the Keysight, again, which is another thing that drives me mad, takes about 45-50 seconds plus. You can see now it's come straight back in and it's remembered all my settings. The only thing it hasn't done is it's gone from measure to statistics, so I'd left it in statistics mode and it had gone back, but it remembers all the settings. It remembers the time base, what acquisition mode this is in, high res, etc. It remembers everything that I set it in, which is rather useful, particularly if you want to set something up and then come back to it the following day. On the Keysight I switch it off and it forgets the time base, it forgets the volts per division, etc, etc. So I do actually like that. I think for that it's got to be left plugged in for it to do that. I haven't actually tried to power it down completely and see what happens with that. It might be worth doing that actually, just to see if it does remember it when one does that, because I'm not sure if it does or it doesn't. So let's just try that. If I switch that off, I'm now going to disconnect the power feed completely. So I've taken the power feed out. Let's switch it back on again to get rid of any residual in the capacitors inside it. Okay, let's now switch this back on again, and let's just see whether it's come straight up to starting straight up again, but let's just see whether this is going to remember everything. I haven't done this before, so I'm not certain. Yes, it does. So that's very impressive. It seems to store inside what it's doing, so that it will come back with all the same settings even if it's been unplugged. I presume that would be even if you left it unplugged for a number of hours. I haven't tried it, but I will try that, and in a later video I'll come back and report on that. But it's certainly useful that everything is remembered, so that if you've done a lot of setup work, you don't have to think, oh, I've got to finish this tonight, or you know, and then when you come back to reset it up again, you've got to note down everything you set. This will actually remember all your settings on your channels, etc., which I think is really great. Okay, that's the power side of it. I hope that was useful. Various people have done power ratings on these. Personally, I don't see the standby current makes an awful lot of difference, because as I said, I switch it off completely. But then of course you can, if it remembers everything, it's easier to do that. Anyway, I hope everyone liked seeing that, and hope that was useful. Right, I've set up the scopes to display a 10 megahertz sine wave, which is coming from an electronics research company 10 megahertz oscillator, which I bought on eBay. It dates actually to 1989. It's a temperature controlled oscillator, but not an oven oscillator, so it just varies it relative to the temperature measured. The frequency on the key site using the frequency counter, which has got the 8-digit specification, is reading 10.000300, and if we look at the Rohde Schwarz counter, that's actually displaying exactly the same frequency, which is rather impressive, which is 10.0003. Again, obviously there's not as many decimal places on the Rohde Schwarz one because the counter on the key site is spec'd with an 8-digit counter because it has a 1.6 parts per million crystal oscillator, oven controlled one I believe, in the key site. But however, the two signals are both being displayed, the frequencies match exactly on the two scopes, which actually I think is quite impressive, and obviously they're 300 Hertz out from the 10 megahertz which it should be giving, so it should obviously be 10.000000, but the oscillator, given that it's from 1989, is about 300 Hertz out, which I believe is in spec for that. I just wanted a cheap way of producing a 10 megahertz signal sine wave to test something, so I decided I would buy one of these from eBay. The seller had 5 or 6 of them, and I decided to buy one having read a review of it. What I wanted to look at now is just the way that the two scopes display that information, and also the wave counts in terms of the statistics on both scopes. So I'll reset up looking at the screen in detail on the key site first. So that's the screen now of the key site 3014T. I've got it displaying the statistics mode. Had that running now for quite a while, probably about 35-40 minutes, and it's got 589,000 count on the statistics, and I've got it set up for frequency, period and peak to peak, which I've done exactly the same on the Rohde Schwarz RTB2004. Basically both scopes are displaying the wave, showing 3 cycles of the wave, or virtually 3 cycles of the wave, and showing the same amount of data. And I just wanted to show that the screen size and the real estate on the RTB again is just superior. I've found recently that I'm reaching more and more for the RTB2004 as opposed to my key site. There is certain functions of the key site, like the mass functions, which I hope that Rohde Schwarz will actually look into now that they've just released the RTM and I think the RTA 3000 series scopes, which have more maths functions. I believe that they're looking, possibly I hope, at bringing some of the functions, I don't know whether it be the maths ones, but certainly some of the UI functions across from the new firmware of those scopes, and there's already a review out on the net, on YouTube, about the RTA, I think it is 3000, or the RTM, I can't remember which one it is, but they're both fundamentally the same. They have sort of double the memory of the RTB2004, and it has better maths functions, and it has better FFT functions, etc. But going back to these two scopes, most of the time now I tend to reach for the RTB2004. I've become so used to it, and I do prefer the screen display on it. It's just larger and clearer, and if you look at the way that the waveform is being displayed on the key site, it's very clean and very nice, but it's just, when you look at the screen, everything is grouped together, and by the time you've got the statistics on, and I was using this the other day, I was logging a PWM signal I was generating, and I wanted to see, which I was feeding into a MOSFET, and I wanted to see whether it was changing over time because of heat variations. I just found that the display on the RTB is just easier, and the accuracy is almost as good really as the key site. So from that point of view, there's very little difference. My key site is only 100 meg scope. Of course, the RTB is optioned at 300 megs. At some point, I may actually increase the key site to 200 megs, but at the moment it's 100 meg scope. We'll look at now the screen display of the RTB2004. Just before we do that, we're up to about 644,000 counts on the statistics, and I had the RTB running at the same time base and the same time I started it, and we're actually at 775,000. So in actual fact, the statistics on the RTB over the same time period has actually created more counts than the Keysight, which is also again pretty impressive, and both are running I think at about 2 meg of memory, because when you alter the memory size it does affect the wave count and the statistics count on the scopes. But let's have a look at the RTB screen now. Okay, now we're looking at the RTB2004 screen, and I've set it up at a similar time base. The RTB is at 25 nanoseconds division. The Keysight was at 30, but that's necessary because of the number of cells across to get a similar display. I've also set it up with statistics mode, which you can see at the base of the screen, so it's got a frequency, period, and also voltage peak to peak, which is exactly the same that I set up on the Keysight in the same order. And you can just see that the waveform is so much larger. I've got the screen split between the statistics and the waveform, and obviously you can adjust that. The wave count is been running at the same time, and I think now that we've got 825,000 counts for the statistics averaging, whereas on the Keysight we've got about 685 or 695,000. So in actual fact it's counted more at the same time, because I started them at the same time. On the top left I've got the counter showing, which is on channel 1, which is the hardware counter, and that's still showing 10.0003, which is the same as the Keysight was showing. On the statistics we've got a frequency, a current of 10 megahertz, and the mean of 10 megahertz. Then you've got the period of 100 nanoseconds, and then underneath that we've got a voltage peak to peak of about 4.55 or 4.54. It's varying a little bit, but those were all about the same figures. But I just find that when you look and compare the display of the two, I just find that this is easier to read, and there's just more, because of the larger real estate on the screen, it's just clearer and easier to read. The Keysight, by the time you put on the statistics mode, it just gets a little bit garbled, although I do like the fact that the Keysight tends to keep the normal measurements down the right hand side of the screen away from the actual signal area, but of course then the signal becomes smaller. But the screen obviously of the RTB is just bigger. I just thought it was worth showing this one to show that the frequency counter on the RTB is incredibly accurate. I think it's got a time base accuracy of about 2.5 parts per million, where clock on the RTB, as opposed to about 1.6 on the 3000 Keysight. But fundamentally it doesn't make a lot of odds for this. They're both incredibly accurate, and most of the time I find that these two scopes give the same information. But I thought that was just an interesting look at the same signal, and how the larger screen on the RTB just makes things easier to read. And there are certain functions, like math functions, which I do still reach for the Keysight, but for normal signals I also think the 10-bit ADC on the RTB, having now had it for 7-8 months, is far superior to the 8-bit on the Keysight. Sometimes it doesn't matter, but there are certain waveforms where it does matter, particularly if you're looking at noise signals or power supply. And I've been doing some work with FPGAs recently, and I've been looking at analog power supplies and buck converters, etc., and I just find that the 10-bit ADC does give a better, clearer signal and shows more detail. There are advantages to the Keysight. Each scope has merits, and plus and minus points, but I must say I am very impressed with the RTB. The more I use it, the more I like it, and most of the time now I use it with a mouse. Still got the same screensaver, still got the same screen protector on it, which has fared perfectly now for the last 6-7 months, and is still stuck to it, and it stops all the reflections that people complain about. I'll actually put the details of what screen protector I'm currently using in the description on the YouTube, because a couple of people have asked me could I tell them actually which screen protector I'm using, and I'll put those details on.